Hello everyone, good afternoon. So guys, can you please confirm that everyone is able to see my screen and able to hear me properly? Okay, thank you Kumar Swamy sir. Thanks for confirmation. So guys, we'll start in couple of minutes. Today's session going to be very exciting. So let me share the agenda with you guys for today. So this is how the agenda gonna look like. So we'll start with the basics of NLP. What is NLP? What is the entire roadmap for NLP? Like if you want to become an NLP expert, so what are the things you should master? So I know like within one session, I cannot take you to that high level, but at least I will try to make you guys reach to that level. At least I will try to make you guys reach to that level. So you guys will be able to understand how to perform this NLP task. So today's session, guys, very exciting because I'm going to show you one live project which is done in the industry, which was the talk of the town a few months back. So that was the movie sentiment analysis on the recent movie. That data was taken for Twitter, raw data, and then how in actually the raw data taken from Twitter can be converted into a kind of a information or a kind of a feedback or kind of a review. So that's going to be super exciting today. Then I will also try to explain you guys the advanced topics like recurrent neural network, how the recurrent neural network works upon. And I'll try to cover one framework, which is the advanced level of the recurrent neural network is LSTM model. So and if the time permits, guys, LSTM model, I will definitely going to show you how to detect the fake news classifier, how to detect a fake news classifier project. So that's going to be a second highlighting project. And then guys, if the time permits also, I wanted to show you one of the chat GPT model, that is GPT 2.5 or 3 model. So where we will try to build download that model, we'll try to build kind of a question answer thing. So if I ask one question, at least it will be able to give me a text back. So some sort of that kind of a demo session, not much. It's very few line of a code, like in 5 minutes of a code we can perform that task. So that's how it's gonna be. So I request everyone once again, all the faculty members, respected sirs, ma'ams, and all the colleagues to please join in fast. In 2 minutes, I'm going to start the session today. So today is our last session. So I want to make it more and more exciting. So hope you guys will enjoy today's session as well. Very innovative session. We'll try to make it today. Rather than talking much, we'll try to make it a more practical towards a practical approach. So you guys are having a complete idea that how the NLP task is performed right from the raw data. So I'll show you like from raw data to reach to the conclusion how the entire prediction can be done. Hope you guys are excited now, everyone. So can you guys give me kind of your thoughts? Excited, not excited, thinking too much? Start interacting with me guys in the chat box. So you can give your thoughts, leave your comments. Yes, sir, we'll get the certificate soon. So once we get this today's session done, so you're going to have a entire feedback with you. And then once its feedback is there, our EDL team will try to arrange these certificates, guys. All right. Thank you very much, guys, for your confirmation that you guys are really excited. Super excited, everyone, I guess. So let's get started in 1 minute or two. So I still waiting for a couple of people to join in. Hope you guys will enjoy today's session as well. Last 1 minute and we can start then. Actually, last 1 minute I would like to give to the people who are able to join in, not join in fast. So guys, please inform your friends, colleagues to join in fast. So respected colleagues, members, teachers, professors, please join in fast. So we can start the session without further delay. I hope this going to be very fruitful session because the entire session will dedicate only for NLP task. Like I'll teach you from the ABC of the NLP, like from where to start the NLP, what to do, what kind of a text pre-processing has to be done first, and all that stuff we'll try to understand today. All right. Let me switch on my camera. Okay. Now I guess, hello everyone. Good afternoon. So you guys are able to see me now, I think. Okay. Thank you, sir. Good afternoon, everyone. Vani, sir, thank you. Vani, ma'am, sir, thank you very much for the greetings. All right, guys, so let's get started without wasting much of the time. So, the meanwhile we start the discussion, I request everyone again to join in fast so they won't miss this exciting project today. So, guys, let's get started. Let's try to understand what is NLP then. So, let me take you to the journey of NLP today. Our today's websites will be dedicated to NLP sessions. So, all right, guys. So, let's understand this one now. So, guys, when we talk about the NLP part, when we talk especially about the NLP part, NLP means totally dedicated towards the human language. Human language. So, let me understand what this NLP stuff is all about. And when we spoke about this kind of AI, machine learning, deep learning, there's a lot of confusion whether this NLP part is a part of the or which is a part of the machine learning, or it is entirely a separate domain, which is a part of the AI, right? So the guys, if you try to focus out here, you will definitely able to understand that this NLP guys, this NLP task is related to where our AI is able to, or our machines, I am calling them machines. Okay, so this AI, so these machines are able to understand, they are able to talk like a human, they are able to interpret like a human, they are able to analyze your language, and accordingly, according to the context, I am using this word context. Okay, according to the context, they are able to take the actions. They are able to take the actions. These actions can be called as a fulfillments. Fulfillments. So fulfilling. So you are speaking to your robot, you are speaking to your machines, and these machines are able to understand your natural language like we are speaking in English. Likewise, you can customize these robots or these machines for your own languages. Okay, that kind of a languages are also possible, like Tamil is there, Telugu is there, Marathi is there, Hindi is there. Many regional languages are available in these libraries. They are supporting the local language, they are supporting even Bengali, Odisha, they're supporting all kind of a languages. And I no need to tell you guys, because the Odisha is the first city, or Odisha is the first state which have developed the news anchor, right? AI based news anchor, which is giving us the news in the AI. So that is the one of the innovation, which is a part of the NLP, right? I'm very proud that this Odisha has come up with this kind of NLP, first NLP chatbot, or first kind of NLP agent, who is called as a news anchor, and she's able to give a news, right? Just like the human beings, she's able to give the news, right? That's an awesome innovation which goes to the Odisha state. So, right. So, not Odisha state, you can say like city or what. So guys, let's try to understand then. Let's try to understand where this NLP falls in this domain. Okay. So guys, when I speak about the NLP, and when I'm talking about the human language and kind of a talk of the humans, and I'm trying to understand these things, how the humans are speaking to each other, and I wanted to understand, and this machine can understand this human language, and they can take the actions accordingly. They can give a results accordingly. So this is in short, we can say is the NLP. So when I say NLP is a natural language processing, right? This is what we speak about, natural language processing, or natural language programming. Someone says natural language programming, but guys, this NLP, they uses the hybrid model. Okay, yes sir, NLP stands for natural language processing. Correct, it is a natural language processing, NLP. So NLP stands for natural language processing, and this is what it looks like. And then this NLP uses the technologies, algorithm which are available in the machine learning, and the algorithms which are used in the deep learning technology as well. So because when we speak about the machine learning, we mostly using the structured data. We are using the structured data, and we are using the algorithm which are based out of the statistical model, mostly the statistical model, which is equal to y equal to mx plus c. This kind of a statistical model we are using, and we are using the structured data. Structured data is always into the tabular format. You guys already know this kind of a tabular format, which is able to fit into the rows and columns. And this is what we are trying to use using the machine learning. And when I talk about the deep learning, we already know we are using this kind of architecture, which is a copy of the human brain neural networks. And these neural networks we are using to solve the problem. And our data is mostly into the part of the unstructured, real subset of ML and overlap with NLP. which comes under AI. Correct, sir. Correct. Your understanding is correct, sir. So this NLP is, guys, it's a intersection of everything. It is using AI technology. It is using machine learning subset of AI. It is using a deep learning, which is also subset of ML, which is subset of AI. So this NLP is kind of a hybrid approach. It uses all the algorithm. And when I talk about the deep learning, especially, so this deep learning uses this kind of artificial neural network, and this ANN, artificial neural network, we already know ANN, CNN, and there is a one more convolution, one more neural network which we going to understand today is the recurrent neural network, which is kind of an advance of all the neural network, which is able to handle the sequential data, and this RNN are mostly used for the NLP task, and the time series related tasks. We'll talk about this sequential data and all. So prior to that, we'll try to understand. So whenever I'm using this kind of artificial neural network, or when we understood this computer vision, when we understood the convolution neural network, we are dealing with the video data, we are dealing with the image data, and we are dealing mostly with the some other complex data sets, right? So this is what we are dealing, and which is a huge data set, which cannot be handled using the normal machine learning languages, right? So this NLP is using all of them, and that is the part of the NLP. Now, once I have understood where my NLP lies, right, it is a hybrid of all the approaches. All the algorithms are used in the NLP. NLP is possible using machine learning, NLP possible using deep learning technology, NLP possible using the artificial neural network, NLP possible using the recurrent neural network. The convolution neural network are specially dedicated only for the computer vision task. They are not used for other purpose mostly. Okay. So guys, now we have a good understanding that this is happening. Now try to understand when I talk about NLP, natural language processing, what are the major tasks? What are the major tasks which are done by my NLP? Which are done by my NLP algorithms? What are my major tasks? First task we can understand is dialogue management. Dialogue management. What is this dialogue management? Let me rub these things and explain you. What do you mean by dialogue management? So guys, we already know that this kind of application exists. Okay. So this dialogue flow, which is developed by the Google, this Amazon Lex, which is developed by the Amazon AWS, and this is the Microsoft boards, which is called as Luis. The name is Luis. This is developed by Microsoft, and IBM Watson is also having awesome AI assistant and NLP assistants, which are called as Watson and Watson X services, which have a special dedicated entire automated agents they have to create to this kind of a bots. So these are bots. What do you mean by bots? Now try to understand. So these bots or dialogue flows, dialogue management. This is called as dialogue management. It is one of the major tasks. So what is this dialogue management? Dialogue management is a kind of a bot which is standing there and giving us a 24/7 resolution to our questions, to our question and answer, kind of a thing. The chat bots. You can say the chat bots, right? These chat bots are called as bots or the dialogue management. We are doing one dialogue. We are delivering one dialogue one by human, and in return we are getting one more dialogue. That is a reply from the bot. Okay, that kind of a question answer, you can say query and text, all these kind of things. Okay. So NLU, natural language understanding, dialogue management, and natural language. No, sir, not grammar. NLG, like NLG is called as natural language generations. You can say generation, because if I give a text, I will come to that. I will explain these things, sir. So you are understanding current only from the NLG. NLG is for natural language generation, guys. Here it is natural language generation. So NLU is natural language understanding. Natural language understanding means if I am providing this text data, if I provide the passage of the text, I am able to pick out the summary. I am able to understand whether there is a positive sentiment or there is a negative sentiment, or looking at the text. Okay, sir. Okay. So looking at the text, guys, looking at the text or looking at the speech, if someone is doing speech, some kind of a speech, someone is doing tweeting, so someone is tweeting something, someone is giving a Facebook live, someone is doing Facebook live, like I am doing this thing, I am doing a YouTube live. So when I'm speaking, when I'm delivering the speech, whether my speech is a hatred speech, whether my speech is a hatred speech, whether my speech emotions, whatever emotions I am having currently, whether I am feeling disgust, whether I'm feeling disgust, whether I'm feeling joyful, whether I am happy. Okay, that kind of a text analysis, that is called as natural language understanding, NLU. And dialogue management, I told you, these kind of tools are available where we can create a question answer chat box. We can create a FAQs. We can create FAQs. Let's imagine this process that most of the times in college campuses, their admission process, this admission process, mostly people comes in, ask many questions, many questions. What is the fees? What are the courses available, right? All kind of a expression of NLU by DM. Yes, sir. Correct. All kind of a expression, all kind of a emotion, all kind of a sentiments. This is created by natural language understanding. Let's imagine, let's take an example, guys, that your college is planning to have some kind of admission, and you are offering different courses. You're offering courses. Most of the times, what you have to do, you have to appoint one counselor. You have to appoint one counselor who is whosoever coming for the inquiries. Whosoever coming for the inquiries, you have to tell them what courses you offer, how much is the duration, what kind of contents are there, how you are covering, whether it's a instructed layer or this is online programming, and then what are the courses, what certificate, what benefit, and everything. All this information now you are telling, right? There is a counselor who is doing this job, and then obviously you cannot provide 24/7. You need to employ many counselors in order to handle this if there are more inquiries. But same thing can be done automatic. Same thing can be done automatic by using this kind of a bots, right? Yes, sir. Real-time example where we want to apply this NLP is, let's imagine that instead of having this counselor, now you have created this bot using this kind of a techniques, right? This bot, dialogue management bot, or kind of a, let's imagine, guys, you are creating one kind of a chat GPT kind of application. Chat GPT kind of application, right? Where question and answers. So you guys can have this develop 24/7, which is available, which can speak like the humans, which is able to take the which is able to take the text command. We can speech command like Alexa. So everyone understand Alexa. Everyone has the Siri, this kind of a personal virtual assistant, right? Virtual assistant like Alexa is there, Siri is there, like many the options are there. All this kind of the bots you can deploy here. Even people can speak to them, even people can text to them, even people can message them, even people can have a conversation with them, and they will be able to explain you what are the courses are there, what is the admission, what is the process. Even you won't imagine what you can do is, you can take the documents, necessary documents, you can ask them to upload the necessary documents, and this bot will verify the documents, it will enter the information in the system, and it will generate the entire receipt, it will make the payments, and your admission will be confirmed. And immediately next day in your mobile phone, let's imagine the admin people, they get this kind of inquiries were received, and this is what is going to happen, right? All right, correct, sir. Alexa, virtual assistant, Google Assistant, banking services. Every banking services has like Deepak, Sipak, Sita, Ita, Ram, Rahim, Mohammed, all kind of people. They have employed those bots, right? So these bots have name like Joe is there, Chris is there, or Ram is there, Deepak is there. I am Alexa. How can I help you, right? All these kind of chat bots are there, like all these things. Like I don't want to discriminate on the basis of the religion or something like that. I'm completely not biased towards anyone. I'm very neutral. I am only understand I am in the India. So that's why I'm taking all the names and example instead of the religion, caste, and whatever is there. So you can create this bot and you can have it employed, right? Not real, but virtual. Correct, sir. It is a kind of a virtual bot, but which gives the entire feeling that you are speaking to a human. You are speaking to human able to understand. An entire process of the admission will be done end to end virtually. Virtually, no need to stand in the queues, no need to ask to anyone, no need to wait, go back. Okay, one time he's saying, please give your admission certificate, give your birth certificate. Next time he will see us telling you, please give us a school leaving certificate. Next time he will ask you, and this way he will at least try to ask you go 10 times and come back, right? No more such thing, no more such thing. Entire thing can be automated using this kind of a things. Then I told you guys that there's also possible that natural language understanding means whatever text is there, we can analyze for the emotions, we can analyze for the speech, whether someone is speaking on the YouTube live or Facebook live, and he's trying to instigate the people. He's trying to instigate the people against some kind of a religion, some kind of a humanity, some kind of against the humanity, against the India, against the country. So you can immediately come to know, you can apply this kind of NLP algorithm, you come to know this guy is doing a hatred speech, and you can block them directly. You can block them directly, okay? So that kind of a things can be also possible. Or you can understand that on the YouTube, on the social media channel, people are sometimes going obscene, right? They are using uploading the porn sites and all sites. Though that can be also blocked. That can be also blocked using the NLP languages, right? So these bots can continuously monitor 24/7 what people are watching, what people are trying to upload. If they find anything foul, obscene, which is not as per the nudity, you can say there is a special models. Whenever we have a special kind of a live streaming, because I worked in the live streaming kind of applications. So this kind of a application like TikTok, like YouTube, like Facebook Live, always these guys try to understand and block the nudity, right? So that is against the law. It is the crime, right? If you try to do this kind of a things, that kind of a bots, that kind of a application can also be created using the natural language programming. So I guess everyone is now very aware. And last thing that what NLP can do is natural language generation. Let's imagine this way, what it can do. So I am going to write a speech. Let's imagine today is tomorrow. Let's imagine tomorrow, 1st of November. 1st of November is a formation day for Karnataka. Let's imagine if I am belongs to Karnataka. Say I'm just giving example. You can belong to any state and you can try this one. So I wanted to give a speech on the day of Karnataka formation, 1st of November, Karnataka formation day. Or let's take example our Odisha state, or any state like we are going, and we have a formation day. And what is my job is I wanted to give a speech, very nice speech to my students, like what is our state, how we are rich in culture, what are our specialty, and how our college is contributing towards this culture, and how we are feeling grateful towards this culture, right? So if you go back to your NLP language assistant application and tell them that this is the occasion, formation day for our state, can you please write a speech for me? It will generate a speech accordingly, right? It will generate the speech. Means what? We are generating something. We are generating the text out here, right? So that kind of a task is also possible, guys. Okay. Natural language generation automatically Kannada speech. Correct, sir. Kannada ಹೇಳ್ತಿದೆ. Tomorrow it will start speaking Kannada of Karnataka formation day. It will giving you the entire speech what you have to speak to the students, sir. Okay. Cool, sir. Correct it there. So this way, guys, so we can perform the task. And then not only this task, let's imagine what will happen. You are providing one image. You are providing one image to your NLP language algorithm. Okay. And that image will be creating, that image will be processed, and it will analyze what lying in the image, what this picture is showing, and the basis of that, guys, on the basis of that, it will generate the caption. It will generate the label for that particular image, or let it be a video. Let's imagine, sir. Let it be awesome, sir. I belong to Karnataka. Okay, sir. I also belong to Kannada. Okay, I can understand Kannada, sir. Nice to meet you. So, guys, try to understand this one. So, when I'm passing one video, sir. Okay. So, when I'm passing one video, okay, let's imagine this video. In this video, there is a small children playing in the garden. There are the small children who are playing in the garden. Are they playing with the frisbee? Okay, frisbee, or they're playing football. Okay, this kind of a video is there. Let's imagine this video is for 2 to 3 minutes. And if I pass this video to NLP application, what will happen? The NLP application will create entire narration, guys. It will create an entire narration that what is happening in the video. So there is a children, there are these many children are there, they are playing in the garden. Some of them are playing football. Okay, that kind of entire text generation from the video, or there you guys already know, from text to text translation, like machine level translation. We are speaking in English, tomorrow it will get converted to Kannada, it will get converted to Odisha language, and that's how it will happen. Or let it be I'm speaking English, it will get converted to German or French or Russian. Okay, all that kind of application, Google Translator, all these are example of NLP. All right, so we have spoken much, I think. So let's go back and understand actually from the front end. Guys, I won't be telling, because now we are very clear that how the NLP task is difficult, because even you speak to your pet, he will understand only few words, he will not understand the intricacy, right? It is like the iceberg. We can simply say the language is like the iceberg. Whatever you see above, there is a much bigger step out there. So it's having a very much large fathom. You cannot reach to the fathom of this entire ocean, right? That is what happens. And that is the language. And that's why we have to have a special understanding of the language. That is not a simple task. That's what we want to say. And this is kind of advanced chatbots and normal chatbots. Like previously, we used to have a kind of an example where press 1 if you want to look your bill, press 2 if you want to compare the bill, press 3 to exit the menu. This kind of a chatbots were there. Nowadays, this is not the chatbots what they look like that. You directly go and speak to your chatbot like, hey, hi, good morning, and my bill this month is showing very high. Okay, this kind of a things you are speaking to your chatbot. What will happen? This chatbot will say, I am very sorry. It will say this way. It is not like the earlier one, like please press 1 to look at your bill, press 2 to look at your 2 months earlier bill. Okay, this is not what going to happen. Okay, try to understand this way. So this chatbot will say, I am very sorry. Okay, this is what they're saying. He say here, he's saying that my bill is very high this month. Hey, can you help me with this one? So it will say, I'm very sorry that your bill is less month. Let's do one thing. Let's analyze your bill. Let's analyze your bill on monthly basis. Let me compare your current month bill with the last month. And then item by item, it will try to compare and it will give you a differences why your bill is more. Okay, that kind of a things is now called as advanced NLP, not like the basic chatbots. Okay, basic chatbot would have given only 1, 2, 3, or 5 option. Please check your bill and go back. Okay, view current summary, make auto pay, or make avail of the discount. Not this way. Now they are what they have done. What they have done now, they have introduced this analysis part here. Analysis part. They have introduced the human touch, human brain part, right? Like the human, you are speaking to human. You human is able to understand your emotion. Human is able to understand your problem, and they are giving you a solution. That kind of a things is now included. Okay. So let's go back and understand that how to start these things. What is this NLP task, right? So we have understood this personal example Siri, like speech recognition, language detection, text to speech. It will be able to call someone. It will be able to give you a kind of a summary, guys. This slide is very important. We'll discuss these slides very quickly, and then we'll go back and we'll try to understand how to start everything. Okay, how to start everything. Guys, everything starts with the neural networks. So artificial neural networks we have to understand, and then we can move to the convolution neural network that we have already covered. So there we can understand what are the loss function, what is optimizer, what kind of optimizers are there. Okay, once you are having this kind of understanding, guys, basic chatbot can't do all the chat translation work. Advanced can do. Yes, sir, correct understanding. So advanced chatbot can do a kind of a human to human interaction, just like the human beings. Okay, and they can understand the problem and they can give you a solution. Okay, sir. So that is what will happen. So guys, how the ladder, how the steps look like if you want to become an NLP expert. If you want to become an NLP expert, how the entire chart will look like, how the steps, how you have to go by step by step. Okay, that is what I am trying to showcase here. So if you want to become a prompt engineer, nowadays there is a very famous thing, prompt engineer, large language model designer, right? Large language model expert, or kind of a chat GPT kind of a application developer you want to become. So where the path goes, what we have to start and where to start. Okay, this is what I am going to speak about. So you have to start with the artificial neural network. Then you have to understand the working of the artificial neural network. What is the loss function optimizer? All kind of a optimizer. How the backward propagation happen? What is the forward propagation happen? Once you are able to understand, guys, once you are able to understand, that is where you can start having a knowledge of how the text data can be analyzed. So text pre-processing. We going to start today, guys, with this one. Text pre-processing or text analytics. Text analytics we going to understand first today. And once we understand the text analytics, then we'll try to understand, okay, this artificial neural ANN part we have already done. Once we understand this, how to perform a text analysis, we'll try to understand the recurrent neural network. This is the base for any kind of a advanced technology, any kind of advanced chatbot, kind of a chat GPT application, large language model, all kind of this application which are available today, where people have went crazy behind this application. These application are a part of large language modeling. All this modeling part is consist of the recurrent neural network. So we're going to understand first recurrent neural network. So I'm going to start here. Then we'll understand the recurrent neural network. Then once we understand the recurrent neural network, I'm going to take you to LSTM, recurrent neural network, LSTM GRU model. And then guys, we also will speak about this word embedding and word to vector. This also I'm going to cover. And this once we cover this, only job you guys will be left with is the encoder decoder model, and this transformer. But these are very, very advanced level kind of a models which have a base in recurrent neural network only. If you are able to understand, how the recurrent neural network works, so you will be able to grasp this. These are the special architecture of recurrent neural network, how they are arranged. The way we arrange the recurrent neural network, they are creating transformer, they are creating the bird. Bird is bi-directional encoding for bi-directional encoder decoder transformation, sorry, architecture for the transformers. Okay, bi-directional encoder decoder arrangement for the transformer, that is bird. Okay, so the transformer and then the LSTM. So we going to cover this LSTM, I will show you, if possible, this encoder, because it takes some time to understand this kind of advanced model, and we'll try to plug and play with this LSTM model today. By using LSTM, we'll try to understand one project. Okay, so I am going to cover the entire part apart from very advanced level topics. So, but whatever knowledge we'll gain today, so we'll be able to understand this kind of a things, and we'll be able to build a large language model also. So, all right, guys, I think everyone is now clear. If you want to become an NLP expert, total AI research scientist in the NLP domain, this is what the entire ladder looks like. This is how you have to complete roadmap you have to follow. All right, so let's get started. Let's get started with the NLP task. So for guys, NLP task, I am going to take you through one kind of a Jupyter notebook where I am going to speak about the text analytics, how the text can be brought into the format. If I provide the text, okay, if this kind of text I am providing, how to perform the text analytics and bring this, so we can apply your model. We cannot directly go ahead and apply model and text, okay, text data. So let me share my screen once again with you guys, and let me show you the data. Let me share my Jupyter notebook with you guys. Just give me one moment, please. So, all right. Okay. Where are you? Text analytics. Okay, yeah. So let me share with you guys Jupyter notebook. Text analytics. All right. So guys, now just quickly, sir, few of us can give me confirmation you are able to view my text analytics Jupyter notebook, and they are good to go. Then we can start without wasting much time. Guys, please give me faster confirmation you are able to see this Jupyter notebook. Okay, I guess everyone is able to see now. Okay. Okay, guys, so let's get started then. Okay, thanks for confirmation, sir. Thank you. So let's get started. So what I have to do now? So what is text? If I provide this kind of a big text, okay, and this is my emotion analysis. Let's imagine when I pass this kind of a text data, when I pass this text data, I want to analyze this data. So what could be the use case I want to perform? That I want to analyze this text, whether I am talking about the positive things or where I am doing the negative things. I am speaking negative or positive. What is this speech also all about? Whether this I am giving a positive speech, whether I am giving it a negative speech. That kind of a things. Let's say this is kind of a classification problem. I provide them. Now my input is text, but my input is text. I'm giving this kind of a big text out here, and then I have to do some kind of a pre-processing. I directly cannot go in and apply my algorithms. Okay, I have to do certain steps, and we'll try to understand what steps we have to do. What are the steps which are basic steps? Why using which I do a pre-processing of my text data, and then once I do a pre-processing, that can be feed, that can become a feed to my model, and my model can give me that kind of a prediction whether this is a positive speech, whether this is a negative speech. I can do a sentiment analysis. Let's imagine we say I can do a sentiment analysis, or I can do a speech recognition, or I can do a emotion analysis, whether these emotions are joyful, disgust, angry, happy, okay, or kind of a calm. This kind of a text thing I am going to do out here. Yes, sir. Correct. We're going to understand this one now. So let's get started, guys. Let's get started then. Try to understand what is the first step I have to do. So, guys, these are the two libraries which we'll be using. One is NLTK, especially we will not use as of now, but it is very useful. Okay, these are the things: NLTK, Natural Language Toolkit, and Spacey. These are the very important libraries using which we have to do a text pre-processing. Now I am going to use NLTK as of now. The first thing I am going to do is NLTK. Now, guys, try to understand when I spoke about the data. Okay, let's imagine I'm passing this kind of an entire data out here. So what will happen? What is the first step I have to take? What is the first step I have to take in order to process my data, guys? So first step is, guys, called as tokenization. Now try to understand what do you mean by tokenization. So when I'm providing this kind of an entire paragraph, I am providing this kind of an entire paragraph. I cannot give this entire paragraph to my model. Whatever algorithm, deep learning, machine learning algorithm, NLP algorithm you are using, I cannot feed this data. What I have to do then? I have two options. One, I can divide that data into the sentences, or I can divide this entire data into the words. Okay, into the words. This is called as tokenization. Tokenization means either I break this data into this kind of a sentences, I separate the sentences this way, or what I can do is I can break the individual words. I can break these individual words, and then I can start by pre-processing. The first step in my data is sentence tokenization or called as tokenization. Sentence or word tokenization. I'm going to tokenize everything. That is the concept called as tokenization. The first thing I'm going to do. So I will show you once. See, this is the entire my passage, the paragraph of the data I'm passing, entire document of the data. Let's imagine I'm passing entire book of data. So this is what happens. First, I had to tokenize them into the sentences. This way, I'm separating all the sentences. You can see that it is the seventh largest country, country by area, second most population country, democracy in the world. India, Bharat, Hindi is the Republic of India, South Asia, right? So this is what I'm doing. I'm trying to break this into the sentences, or this is what is called as word tokenization. Every word, every comma, every parenthesis, everything is getting separated. Everything getting separated. How to perform this one? Try to understand. Import NLTK, pass your data to called as sentence underscore tokenize. This will create a sentence tokenization, and similarly, you have a NLTK dot word tokenize. You can pass the data, it will tokenize everything. Now try to understand, guys. Now try to understand what is my problem out here. So when I tokenize this data, and what is my main job? I want to understand, analyze this data, right? So when I tokenizing this data into the words, what is happening? The words are coming along with the words. I have this kind of a punctuation marks, colon, semicolon, commas, parentheses, all kind of a expressions are also coming, all kind of a regular expression, you can say, of kind of a entire special characters also coming. So that is my main problem. And then try to understand one more problem. So when I'm trying to separate this one, let's imagine this entire words are coming towards the 1,000. Let's have these words. When I count them, these are the 1,000 words. 1,000 words means when I pass this 1,000 words, that 1,000 words will become 1,000 columns. 1,000 columns. And then if I pass my 1,000 columns, my model will go crazy, right? So this is just the one small text. So this way, if I pass my entire book, what will happen? Billions of columns will be there, and that will become very, very difficult to analyze this data. So that is the first thing I have to do is, is there a something so by using which I can reduce this dimension. Okay, so that is the first thing I have to understand. Without changing the meaning of my text data, I have to reduce the dimension. These are the two things which I have to understand here. So for that purpose, what I have to do is, I can understand something called as stop words. Now try to understand the next concept. Okay, I'll come back to this POS tagging and chunking later on. So first thing we need to understand is the stop words. What do you mean by stop words? So when I read this entire sentences, in the sentences, we will have a words like a, and, the, etc, all. So you can see some example. I have written here NLTK corpus. From NLTK corpus, we are importing the stop words, and stop words especially for the English language. You can provide here Hindi language, Odisha language, you can provide Kannada, Telugu, Tamil, Marathi, Hindi, everything. All this supports, all this NLTK supports this kind of language. Now, what I am trying to do, guys, try to understand here. Yes, sir, correct. We are going to reduce the text by the optimization and by the cleaning method. That is why we are using the stop words. Now, try to understand. If I say one sentence, if I write one sentence, my name is Vikas. If I am saying you this sentence, let's imagine someone only says and I am going to cut this sentence. Name is, I am going to cut this. My Vikas. My name is Vikas, right? So my Vikas. If I say you only these two words, immediately you will be able to understand. Even if I drop these words, I will be able to make a sense out of that. I am talking about my name. That I am a Vikas. I no need to write in long form. Still, I can analyze my words. Still, I can analyze the context. I can analyze what I'm trying to say. So same thing we're going to do here. So these words which are frequently appearing, which are not important, this kind of words A and B is there, where you can see this entire list is there. Yourself, you, me, there, their self, itself, belong, if, but, why, up, down, there, where. Okay, this is the entire list. This list I will reduce, guys. If I reduce this list, still my meaning will not change. My meaning will change. There will be difficulty to understand. I can understand. There will be difficulty to understand the meaning, but I will be able to bifurcate. I will be able to understand the entire summary of my words, right? And this way I can reduce my dimension at least and make my calculation very easy. That is called a stop word. Then how to remove the stop words? Yes, something called a stop words, and there is this kind of a expression. Because I don't need this kind of a special character to see, right? To understand the meaning, I can remove this string punctuation marks also. So this is the next step I'm going to do. I'm going to remove the stop words. I'm going to remove the punctuation marks. So from my words, this will bring down my dimension. Now how to perform that? Try to understand this way. I am importing the stop words and I am creating something called as punctuation marks, string dot punctuation, this kind of a marks. Then I am putting, simply taking my data, whatever data I have, I am taking my entire data and then bringing this kind of a loop out here. Which loop, what will do? Try to understand here. NLP dot word tokenize, word tokenize. First, I will break them into the words. Then I will compare one by one. Let's imagine this way. I will compare India. This is my first word, India. Now, whether this India is present in punctuation marks, if yes, then it will not take it in the clean data. Otherwise, it will go and check the second condition. If it is a punctuation mark, is this India is not a punctuation mark, whether it is a stop word, yes or no. If it is not a stop word, then I will append to the clean data. This way, guys, this way it will check India. India is not present in punctuation mark. India is not present stop word. That is taken here. That is taken here. Then parenthesis. Parenthesis immediately it is present in the punctuation mark. It is not taken. That is why we have taken then Hindi. And this way, guys, this way I have cleaned my data. This way I have cleaned my data, right? So now my data looking great. Now my data looking great. Now try to understand further what I can do. Further what I can do. Once I have removed my stop words, once I have removed punctuation marks, once I have removed my special characters, and then what is the next thing I can do? And I can still go ahead and remove or reduce the dimension, guys. So any guesses, guys? Any guesses? What else we can do? Let me understand from you guys that what could be the more thing through which, without changing the meaning, we can do a further reduction of the data. Anything coming to your mind, guys? Any thoughts? What could be the useful use cases? What we can do further to reduce this, to bring down to the normal level? Any suggestions? Anything we can do, guys? Please let me know in the chat box. Okay, quickly, what we can do now once we perform this kind of a now cleaning. So that is why the main topic will come called as stemming and lemmatization. Before I discuss this, guys, let me know if you have any thoughts, like what we can do out here. So any thoughts, any kind of a things, guys, any suggestion? Further, what step we can do in order to clean our data, to bring down our dimensions? No, guys, no, any thoughts? Anything coming to your mind? Come on, guys, quickly try, at least some of us. Comparison of text in the databases. Sneha Kumar sir, Sneha Kumar, Shalini sir saying the synonyms. Correct, awesome. Kumar Swami sir is also saying correct. Comparison of the text in the database, similar short term length words. Correct, guys. Correct. Awesome. You guys are going in the correct direction, sir. Correct. Okay, what we can do is now I can try to find out. Let's imagine that concept is called as, guys, that concept is called as stemming and lemmatization. Now try to understand what do you mean by stemming and what do you mean by lemmatization out here. So what I have to do is, guys, let's imagine these words: running, runs, and ran. All these are coming from the base word run. So if I try to bring down this word running, run, and ran, okay, to the basic format, so that will be great. If all these three words are there, instead of three words, I can use a single word, and this way I can reduce my dimension. Similarly, I can find the similar words also, and I can do the these things. So guys, this stemming and lemmatization, this is called as bringing the words to the basic format. Okay, tokenization lemmatization. Correct, sir. Correct. So we are doing this stemming and lemmatization. Both are synced. Both are doing the same job, bringing the sentences of words to its basic format. Apart from only one thing, apart from one differences, stemming don't look at the meaning of the word. Stemming don't look at the meaning of the word, and lemmatization try to understand the meaning, and then it will try to bring down to the basic format. Try to understand now what. So let's imagine if I perform a stemming, then like 3 or 4 kind of a stemmers are there. Lancaster stemmer is there, Snowball stemmer is there, Porter stemmer is there. Various stemmers are there. I will not go into the detail. You can use any one of them. Both are good, but try to understand what is the basic difference between stemming and lemmatization. Lemmatization will understand the meaning of the word, then it will bring down or chop down to its basic format. But this stemming, without looking the meaning, without looking at the meaning, it will chop down to its basic format. That's the difference. Let's understand how. So these are the things. Okay, these are the things. Lemmatization, typo, mistake, or error. No, sir. Try to understand. Lemmatization will try to understand the meaning, then it will bring it to the basic format. Actually, we'll understand, like you try to see here. Then you guys will understand the difference, like what is happening actually. But I will ask you also question, which one is better. Okay, let's try to understand, guys. Let's try to understand. So if I say running, runs, and ran. Okay, if I bring them to run, it is okay, right? My meaning is not changing. Let's imagine this kind of a words: computation, computer, and hobbies. Computation, Okay, guys. Okay. Thank you, guys. Okay, sir. Understood. So guys, try to understand this kind of a word: computation, computer, and hobbies. Okay, computation and computer. Let's understand this way. What if I chop them? If I chop them to the basic format like compute, the entire meaning is changing, right? Compute is computation, okay. But if I chop the computer as compute, entire meaning is changing. That's the problem. That's the problem with the stemmers. Stemmer not looking at the meaning. Stemmer not looking at the meaning. They're chopping to the basic format. Okay, hobbies are coming hobby. So this way. So that is the problem, guys. That is where these kind of things are coming up, which is called as lemmatization. Lemmatization. Now try to understand. Lemmatization is a very costly affair. Okay, very costly affair. So I am giving this example. You can refer later on. Porter, Lancaster, Snowball, what they are doing. Very small difference, but they are doing the same thing now. So okay, try to understand now. So that stemming, when I apply this stemming, guys, try to understand this way. You have to import these stemmers, and whatever stemmers are there, you have to pass in the porter.stem. You pass the word or document, it will try to stem down. Okay, stem down. So this is a simple code out there, or you can pass the entire thing like this. You can put a one kind of a stemmer and you can try to pass through the entire looping through. Okay, it will try to stem the loop. But try to understand lemmatization, what happens. So when I said that lemmatization, try to understand the meaning, grouping the words with the similar meaning. Correct, sir? It will try to do that way. But guys, when I'm using the lemmatization, which is this way, I'm calling from stemma. Stemma is kind of, guys, stemma is a kind of a Greek word, stemma, which belongs to the stem or root of the tree, right? That is what is stemma called as the English word. But from there, they're doing the stemming and lemmatization, stemma. Okay. So guys, try to understand. When I want to understand the meaning and then want to chop down the words like this one, running, run, and ran. Okay, what will happen is, guys, I cannot chop down directly. See what is happening when I'm passing this word net lemmatizer and passing this words as it is. It has not done anything. It has passed as it is. Why? Because, guys, in order to understand the meaning of the word, I have to do something called as POS tagging. Something called as POS tagging. Now the POS tagging concept will come into the picture, guys. So POS tagging, try to understand POS tagging. So this thing, part of speech, okay, part of speech tagging. Now to understand, guys, in our normal language, there are a 6 part of speech, but here in the NLTK, there is a 9. I will tell you what is the difference. What is part of speech? Like I am trying to understand whether it is a verb, noun, adverb, adjective. Okay, so that kind of a things, and that is what is called as part of speech. Once I give a part of speech tagging, then only I will be able to understand the meaning of the word, and then the lemmatization will work. Okay. So try to understand why there is a 9 part of speech instead of 6, which are in the English language. So guys, here it is trying to bifurcate between the singular form and plural form separately. So you can say noun, but if noun is singular, it is called as NN, noun singular. But if noun is plural, it is called as NNS. NNS. So that is why they have a more part of speech here in NLT collaboration. Okay. So this way, guys, once I import this POS tagging, obviously, so this is the way how I do a POS tagging, NLTK.POS underscore tag. And once I pass this token into the sentence words, and this will give me directly this kind of a mapping. V, pronoun, this will, this word, verb, C, verb. Okay, this kind of a noun or this kind of an entire thing will be given. So I can create I can create my own grammar also. That is called as parsing. That is called as parsing and chunking. So if you are not happy like the way you want to write this way, you want to club a verb and noun or proverb together, that is also possible. See here what we're trying to do. We are creating noun, pronoun, and multiple from noun, pronoun, and multiple noun together, and we're calling as a MN. This kind of a own grammar rule I'm creating. That is called as chunking. Okay, regular expression chunk.parse. So you can say it is taking this noun and singular and pronoun as together one. That is MN. So, right? So I can create my own rule also. That is called as now chunking. Yes, guys. Yes, correct, sir. You have to tag the map of the tokens. Okay. So this is what we are doing. And so once I am able to, guys, do POS tagging, then my lemmatization will start working. And now you can see here, once I am passing here POS tagging, okay, then I'll come back to entity recognition. I'll come back to this entity recognition. So you can say once I am able to pass, okay, once I am able to pass this kind of a thing, it will able to do a lemmatization. POS tagging. See here. So I am doing POS tagging, then I am doing chunking, and then I am trying to do a lemmatization. Okay, this is what will happen. So here, lemmatization, lemma.lemmatize. I am passing this word running, and I am passing a POS tag as well. Once I do a POS tag, guys, now you see running, runs, and ran all came back to its basic format because it is trying to understand the meaning as well. Okay, so that is what the pre-processing I will do. Then guys, what is the next step? What the next step? Next step is called as name entity recognition. Name entity recognition. What do you mean by name entity recognition? Now let me list down what we have done. So first I did a sentence or word tokenization. So this is what we understood, tokenize. We are trying to tokenize the things, means breaking the entire things into the words or sentences. Then I removed my stop words. Stop words. I removed my punctuation marks and I removed my irregular expression, which are not useful. Then then I did a stemming. Then I did a stemming and lemmatization. Lemmatization part I have done. So this way I have reduced. Now, then before that we understood the POS tag. What is part of speech tagging? Once I do part of speech tagging, this lemmatization will work very well and you will try to understand the things. Okay. So token lemmatization, POS mapping, parsing, correct, sir. So correct, this is the way. And once I am performing this operation, then what I have to do is because try to understand guys, whatever the text data is there, text data I cannot take as it is. I have to convert that text data to the number format anyhow. I have to convert to this number format. And that concept is called as very famous concept in NLP, what to wake. That we going to understand now. What to wake, what to vector, what to wake. That is convert this text to numerical data. So let me understand now. Once I have done this kind of a pre-processing, okay, POS tagging, lemmatization, stemming, stop words, sentence tokenization, then I have to do last thing in order to understand the meaning of the words. Name entity recognition, NER, name entity. What do you mean by name entity recognition? Try to understand now here. So let's imagine this way. I have this sentence which is called as India, officially Republic of India, is a country in the South Asia. Now, guys, when I say country, so you guys need to understand, when I talk about country means I am talking about a geographical location. When I am saying India, India is a country. South Asia is a region. So this kind of a mapping is called as name entity. Means I am trying to find out which entity is present, whether the person is present, whether the geographical location is present, whether I am talking about the person, whether I am talking about the place, whether I am talking about the city, whether I am talking about the map, whether I am talking about the money, whether I am talking about the animal. So this kind of a things is called as name entity recognition. So once I understand people, place, countries, entity, things together, then finally I can get to know my meaning of the words. Right? I can understand the entire text before I convert them to the numericals. So that is the last thing. What I have to do is name entity recognition. So there is a something called as NLTK.any chunk, and you can have a name entities. You can print the name entities. The moment I pass, guys, this document, you can see here it is able to understand this kind of a mapping. So India is a geographical location. Republic is the organization. This is the city. This is again a geographical location. South Asia, okay, this kind of a things, organization, people, person, date, time, money, percentage, facility, okay. So this you can see example, organization, George Specific Corporation, this is the organization, Eddie Bonte, this is the person, President Obama, person, location, Mary River, Monty Everest, okay, this is the date, June, this is the city, this is money, right? When I talk about 75 million, when I talk about dollar, when I talk about rupees, I'm talking about money, I'm talking about time, I'm talking about date, I'm talking about facility, I'm talking about organization, I'm talking about people, okay? So this is what is called as, guys, this is what is called as name entity recognition. What to assignment of numbers to words or tokens. Number to words or tokens. Guys, words, it is called as words, okay? Name entity recognition. Correct, sir, correct, okay? Correct, your understanding is correct. It is word to vector, means not to token. Or token, you can say token is also kind of a, you can say token is somewhat like it's a expressions, guys. Token, we can say, when we talk about the large language model, token at that time will consider as the queries we are writing in order to extract the information. So guys, the parsing, we already spoke about this kind of a recursive parsing and all. So let's, guys, once I am able to do this name entity recognition, then what I have to do is I have to confirm a word vectorization. Means that is my final step to convert my words into the kind of a numbers, So that is what is called as word to vector. Guys, try to understand here what is happening out here. I'll also tell you like word embedding using the deep learning, using the Kera, what it does, and what is very, very famous concept that is called as feature mapping. Feature representation, feature encoding. Feature encoding will help us to reduce the dimensions further. I'll speak about it in the meantime. I'll speak about this one. Let's try to understand this word vectorization. Okay. So what I'm going to do, there are two methods. One, I create a bag of words, means whatever words are there, I'm just counting these words. You can see here, I came 2 times, went came 1 time, this kind of a number counting. That is called as bag of words. or there is also n-gram method. Like rather than calling one word at a time, I take a 2-word or I take a 3-word combination. Okay, that is not important. That is very simple. But what is important is, guys, this concept: term frequency, inverse document frequency. This method is also word to vector method, and very, very important method. I try to understand what will happen here. So here we have to convert the the word into the numbers, but there is a some special way how we are converting now here. What they are doing is they are giving weightages out here. So rather than simply counting the frequency of the words, they are also giving the weightages to the words which are not coming frequently, because what is going to happen is whatever the unnecessary words are there, those words are coming many times in the sentences, but the necessary words comes only once. So we will be able to give a weightages to those words. That is what is happening, and try to understand how this is happening. TF IDF vector. So term frequency, inverse document frequency. So how to calculate what is this is all about. So let's imagine this way. So we'll try to bifurcate it into two terms: term frequency and IDF, inverse document frequency. How to calculate term frequency? Try to understand now. Let's take the example. So this is my one document. Now I am taken very simple example, but in one document could be thousands of sentences possible. Okay, thousands of sentences. Eliminate unnecessary words and repeating of the words. Correct, sir. So what is happening actually? I want to give a more weightages to the words which are meaningful and less weightages to the word which are not meaningful, along with the normal counting of the numbers. Okay, while I convert this into the numbers. Okay, that is my main aim. That is why I'm doing TF IDF. Now imagine this way: whatever word is there, if that word is coming very frequently in the all the documents, that means it has certain meaning and it is important. I want to focus on that kind of a words, which is not unnecessary words which are repeated again and again. Okay, so that is what is happening here. Try to understand how to calculate a term frequency. Simple term frequency formula says the number of times word is appearing in the document divided by total number of words. Total number of words in the document. Number of times word appear divided by total number of words. Let's imagine this example. Document number 1. So I want to calculate the term frequency for document number 1. So let's take example this word. This is an example. This sentence I have taken. Here this is coming only once. This is coming only once. So I say 1 divided by how many times it is coming? Once. Divided by total number of words. Divided by total number of words. Total number of words are 4. So my term frequency becomes 0.25 this way. And if you calculate for everyone it will be 1/4, because everyone coming only once, and once but divided by total words. So this way, guys, you can see here when I calculated the term frequency for this word, you can say it is 0.25, 0.25 out here. Okay, this is what the term frequency is all about now. This is how I calculate the term frequency. Now try to understand how to calculate inverse document frequency. So what's the formula? What is the formula for inverse document frequency? Number of documents. Now I'm doing reverse. I'm doing reverse of what? I'm taking the ratio of the frequency. I'm reversing it. So I'm taking number of documents first divided by the number of document word appear. Now try to understand what then. And then in the end, I will take the log. Okay. Try to understand this word. Again, same word I am going to understand. This word, okay, there are in total 3 documents. This is document number 1, 2, and 3. How many documents there are? 3. Okay. Out of that, so in document number 1, I am talking about this word, this. Okay. So this is coming only once now. Only once in first document. So in second document, is it coming? No, 0. So in third document, is it coming? No, 0. Means in number of documents word appear. In how many documents word is appearing? Only 1 document. Then above, what I have to write? Above number of documents. How many documents are there? 3. So the inverse document frequency, and this is not done. I have to take a log of it. I have to take a log of it. So this is how I calculate inverse document frequency, IDF. Okay, IDF. And then whatever number will come, that will become my weightages. That will become my weightages. Try to understand what they have done. So here you can see here. So for word this, the 1/4, that is 0.25. Then 3 divided by 1 is 3, and log of 3 coming to 1.59. So guys, this way I calculate term frequency into document frequency, and once I calculate term frequency multiplied by inverse document frequency, this is how I get my final score. So I'm multiplying this 0.25 by 1.59, and this is how I get in the end my scores, guys. This is how I get my scores for all the document wise. How to implement this one? Simple. So from ExcelR feature extraction, import the TF-IDF. So call this TF-IDF vectorizer, and then within this vectorizer, guys, pass your document. And the moment you pass, you write this TF-IDF dot fit transform. TF-IDF dot fit transform. Pass the document, and this is what the number will appear. See here, the numbers are appearing. So A, B, and confusing example how TF-IDF works. This entire sentence I have passed. and it has created me the numbering system along with the weightages, TF-IDF score. Now what will happen next? Okay, term frequency, I'll explain again. Once again, term frequency. Term frequency is simple, guys. Try to understand what I'm trying to calculate. Let's understand this way. So term frequency is number of time word appear divided by total number of words. So let's take the example. So I'm taking the example of is. So this is one document. For one document, I'm calculating the term frequency. So is coming how many times? Only once. So what is the total number? It is coming only once. Divide by how many words are there? How many words are there? 4. So 1 by 4. So that is called as 0.225. This is term frequency. If I want to calculate IDF, inverse document frequency, what I have to do? So this is a formula reverse way. So what I have to do is, let's imagine total documents. Now they are not talking about one document. In total document, guys, okay? If the word repeat, obviously, if you do not repeat, let's imagine it is coming 2 times. I'll divide by this 2 divided by 4. Whatever comes in, that will be my term frequency. Okay, this way I will do it. And IDF is now how many documents are there? So that documents I am writing total number of documents 3, and then out of that documents divide by how many documents this word appear. Is coming only once, so divide by 1, so that is 3, and then log of 3. Then whatever this term frequency is there, multiply by IDF, that will become my final score. Okay, this way I'm going to calculate, guys. Okay, and once I calculate, I pass this TF-IDF vectorizer and TF-IDF fit.transform. I passing my document. I directly get this kind of a table. Now what, guys? Now what? Once I got the table, what is the use now? What I am going to do now? You can do anything. Let's take the example. If you want to do, you have to apply any kind of algorithm here. Classification algorithm. You can apply random forest. You can apply decision tree. You can apply SVM, or you can apply the best algorithm, which is called as naive-Bayes algorithm. Naive-Bayes algorithm always works based on the text data. So naive-Bayes algorithm always works on the text data. So if it is a 2-class binary class classification, so you have to take naive-Bayes, normal naive-Bayes, Gaussian naive-Bayes, Gaussian NB model. If it is a multi-class classification, it is a multi-class. If you want to understand 5 emotions, here I want to understand only sentiment, plus or minus. So you take Gaussian naive-Bayes. If it is a multi-class, you take multinomial Gaussian naive-Bayes model. Okay, this kind of a models you have to take, and you have to apply here, and then obviously you get a probability. Once you get a probability, what class it belongs to, max of the probability is my final result, guys. That's it. Yes, sir. TF-IDF is very important. Otherwise, I will tell you also the advanced method which are used in the deep learning. The advanced method is called as word to vector embedding. Something called as embedding layers. In Keras, like in deep learning, we are using embedding layers, by using which we are converting this text to the numbers, and we are also bringing the dimension back to something called as feature representation. So by this way, we can also perform. I guess, guys, everyone understood now how to pre-process the data, how to convert them, this pre-processing. And once we convert them, guys, we have to apply this algorithm, classification algorithm, or our naive-Bayes algorithm is very important in the class data, in kind of a text data, and then we get our final result. So let's understand. Let's have a code walkthrough now. I am going to show you this code walkthrough now for very famous example, which was the award-winning example of implementation, which is called as now movie sentiment analysis. I am going to take a Twitter data. Let me share my screen quickly, and let me share you back, and let's make this live project with me. Okay, so let me show you this project now. Let's do a live project out here. So how to perform this kind of things. Okay, so let me share my Jupyter notebook once again with you guys. All right. So guys, quickly let me know if you are able to see my Jupyter notebook, Adi Purush movie sentiment analysis. This is what we're going to do now. This is award-winning implementation. All right, sir. Thanks for information. So let's understand then how to perform this task. How to do a movie sentiment analysis using the same concept we have learned here. So this movie, everyone knows, this has been released in the month of the June 2023. So what people have done, I will explain you what is this things we're going to do here. So I am collected the Twitter data, guys. I am collected the Twitter data for this movie, and this is what the data looks like. You can see here. So these are the actual tweets we have taken from the Twitter. These are the actual tweets, and these tweets are downloaded by using the Twitter analysis, by using the web scraping, using the Twitter. They have downloaded these actual tweets from the people, and this kind of a tweets are taken into the CSV file. I am reading this CSV file as a data frame. as a data frame. Okay, guys, I will share this code with you so you guys can know like how to do a live corporate project, live corporate project only. So now here you guys can see we have a raw data, very raw data, direct data taken from the Twitter. Okay, direct data taken from the Twitter. So you can see here how the data look like. Data only has the 4 columns, only has 4 columns. What is the date, timestamp, what is the number of likes given by that people to this kind of a tweet, and what is the source of the tweet, means who has tweeted this, and what is the tweet, actual tweet. You can see here. So live Twitter data, you can see the multiple emojis are present, multiple hashtags are present. You can see hashtag England versus Australia, hashtag Adipurush, hashtag now playing, book your tickets, hashtag like this kind of a camera sign, emoji sign, at the rate Ponile Muva Adipurush, right? Whatever comes to mind. And guys, what is the amazing stuff? Amazing stuff. Try to understand. This data we have taken 10,000 records, 10,000 tweets we have taken, 10,000. Okay, not a single data we have taken, 10,000 tweets we have taken. And then you can see there is a mix and match. There is not only English, there is a Hindi also. People are writing in Hindi also. Vastav mein yani Adi Purush. Okay, you can see this is about a Ramayana hashtag, Shiva Home, Elevate, Let's Power. This is a mix. This is called as English, guys. This is, you'll shocked to know there is some library which is supporting English. English, it is a mixture of Hindi plus English. That is also supported in NLTK. That is also supported in NLTK, guys. Okay. Multiple languages, 10K tweets. Yes, sir. So we are taking these tweets. Now, what is our main aim, guys? What is our main aim now? Let's try. Let's apply the same thing. Let's start doing the text analytics. Let's start doing the text analytics. Now, one by one, I will start my pre-processing steps. One by one, I will break this into the words. Then I'll try to clean them using the stop words. I'll remove these punctuation marks. I'll remove this kind of entire emojis. I'll remove the unnecessary columns. I'll try to bring them. This kind of tweets are there. I'll try to bring them into the English language. If not possible, I drop them. Then I will try to filter my data out of this 10,000. All kind of things. All kind of pre-processing I will do. And in the end, guys, I'll convert them from word to vector. Or maybe I can create a TF-IDF. I can create a TF-IDF. Or I can use a Keras. I can use a Keras library. Keras layer of the word embedding layer. Word embedding. Very advanced concept. Keras word embedding. So through which there's a one more thing which is called as feature embedding. Very advanced concept through which we can convert this 10,000 kind of images data. This kind of 10,000 dimensions. You can say 10,000 dimensions. I can convert them to the 40 dimensions. That kind of a huge power is there in the Keras layers. Okay, that is called as word embedding. So I'm going to perform this, guys, live in front of you. I'm going to show you how to perform, and we try to understand whether people like this movie or they don't like, or they were neutral about the movie. Okay, that kind of result I'm going to achieve out here with you guys. Now try to understand first thing what I'm going to do. I have this data, dates, number of likes, source of the tweet, and what is the actual tweet. Only 4 columns and 10,000 records I have. So I'll check my shape of the data. I am also checking what are the columns I have. And then, guys, I'm trying to check first thing, which is duplicate. How many duplicates I have? So when I say df.duplicated, I have only one duplicate. So I'm dropping that duplicate number. Okay. I have dropped the duplicate. The moment I check the duplicate number, then I'm checking, is there any null values present in my data? Is there any null values present? If the null values present, obviously, I'll get a count. Now, fortunately, there are no null values. Okay. Source of tweet is a null value. So because the source of tweet is not given anything, there are null values. So I can drop this entire column. I can drop the entire column. There's a 10,000 null values, means source of tweet is not given. So that is what I am getting 10,000 counts for is null sum. That's it. So I drop this df.drop source of tweet. Now I have only 3 columns here. Tweet, number of likes given by the people, and date created. Now what I can do is I can even transform my data. I can do a feature engineering. I can separate my dates and times. And I can do my text pre-processing as well. I can do a text pre-processing. So let's do this. Okay, ma'am. Yes. So I will ask my colleagues to mail these recordings and all. Okay, cool. So guys, try to understand what I have to do now. So I am trying to understand what are my data types by using df.info. And once I do, I can understand the describe, like what is my mean value, median value, how many counts I have, all kind of a statistical analysis I'm going to do, guys. All kind of a statistical analysis I'm doing. Then, guys, once I'm trying to understand in the likes, what are my unique values? In the likes, what are my unique values? What people have done. So in the likes, you can have people created number of likes and tweets. Okay, people created only number of likes and unique in data frame. Okay, and unique date created, number of likes, and with these are my unique values per column. Okay, so guys, once I do this, what I can do is now I can sort my data. I can sort my data by number of likes, So once I sort my data by number of likes, guys, I can come to know immediately which tweet is liked many times by the people, which is the highest tweet which are liked by people. So you can see this is the tweet. Prabhas clearly said no. Dear star. So this has got a 14,000 likes. Highest likes. This tweet got the highest like. So this way, guys, I can say Adi Purush Nirmato ko laga ek jhatka Ilhabad. 7,000 likes. Okay, Adi Purush. You can see everything is mix and match, guys. Very, very raw data, actual data we are taking. We are trying to understand how many likes are getting. Then once I understand, guys, what I can do is now I can convert my date column. I can convert my date column to PD date type. So this is what I'm doing. Guys, one by one, I'm doing all the presentation, one by doing all the representation. One by doing, I will be doing the all the cleaning. Now try to watch how I am doing these things. Okay. Yeah, correct, guys. Correct. This is what we're going to serve. Correct understanding. Okay, so once I've done this, guys, what I'm going to do is once I'm able to separate this date and column, and once I'm converted to the date and time. So what I can do is simply I can plot my graph on what day, how many likes were given for the tweets, right? On what day, how many likes are given. I'm just simply doing the plot, plt.plot, and number of likes versus the date. Number of likes versus the date. I'm seeing how many likes per time. So this is what I can create, and I can create a scatter diagram also here. Same thing. How many people given a like on which date? Okay. This is the one thing. This is the one thing I can do. Now what I can do is, guys, now I am going to do an actual job. Now try to understand. I'm going to start my stop words. I'm going to start removing the punctuation marks. Then, guys, something very important you have to understand. I'm going to create, guys. I'm going to create this kind of amazing stuff also. You try to understand here. I'll show you. Like I'm going to create an amazing stuff like this one. Word vector. Okay. So let me show you what is a word cloud. Now word vector. This one. I have to create this kind of a word cloud. This is called as word cloud, which is able to give us that what is my word, which is getting repeated most of the times. The most repeated words and the important words are highlighted. This is word cloud. So I'll show you how to do word cloud. Then I will try to understand how to create which is a positive sentiment, which is negative sentiment. Okay. So let's try to understand, guys. Try to focus out here. How to do a real job now. Till now we are just played with the simple task. Now try to understand what is the real job I am going to do out here. So one able to understand how many likes are there. This is very simple representation. You can guys do as per your convenience. What is the representation you want to check? Now guys try to understand very important function out here in the NLTK.sentiment, guys. NLTK.sentiment. Because now what is my problem? Try to understand here. Guys, whatever data I have, I don't know whether this data belongs to positive class or negative class. If I don't know actual my training data, because I have to train my model with the data and I have to give a labels to my data, which is the positive sentiment, which is the negative sentiment, which is the neutral sentiment. This kind of a bifurcation I don't know because I only have a Twitter data. So my next task is to understand which tweet is positive tweet, which tweet is positive tweet, which tweet is negative tweet, which tweet is neutral. They are not talking about it. That kind of a stuff I have to create. I have to remove this punctuation marks, stop words, everything. I have to filter out the data. All this stuff I'm going to do now. Guys, try to understand what first thing I'm doing here. I'm calling one function which is called as NLTK.sentiment vector library. So sentiment intensity analyzer. Very, very important function, guys. I am going to call this function as SIA. Okay, sentiment intensity analyzer. So try to understand what I'm going to do with this one. So I told you word cloud also. I'm going to import a word cloud. Okay, and then stop words. And then I'm going to import the stop words and I'm going to do all kind of a cleaning which is required now. Try to understand. Now you can see here, guys, in the stop words, I'm checking what are the supported languages. What are the supported languages in the stop word? You can say Arabic, you can say Bengali, you can say Chinese, Danish, Greek. What is more important? Hebrew also they have. Hebrew, okay? So they have this kind of a Hindi. But one thing very interesting is this one, English. Hindi plus English. This kind of a mixture is also available, guys. Yes, correct, sir. Kumar sir, correct. This is what we're going to do. We have a Turkish, Nepali, all kind of a language, local, global, all languages are possible, guys. All languages are possible. Now try to understand what I'm going to do. I'm going to create a stop words in English and English, guys. Both the stop words I'm going to bring and I'm going to clean this kind of data. Hashtag, special emojis, /sign, oblique sign, HTTP, all these kind of things, okay? Special characters, hashtags, URLs, all go with this. This I am creating one kind of a list. Then I'm creating one kind of a tokenizer. By using tokenizer, I'm going to convert them into the words. Once I convert them to the words, I'm going to call this stop words, English Hindi stop word, and going to clean them. This is what I've written here. And once I call them one by one, guys, so this will go through one by one, tokenize them, and then I try to clean my data, guys. I try to clean my data. This is what I'm going to do here. I'm writing tweet dot subplot, then I'm trying to create this tokenizer. Whatever tokenizer this, I am going to pass my tweet column. This tweet column I'm passing, which is my actual column. This tweet column I'm passing into my tokenizer. Okay, once I pass this into the tokenizer, I'm going to make them into the translate to the lowercase, guys. Because try to understand this thing, I forgot to tell you. If this is some words are in uppercase and some words are lowercase, that is also the problem. So that's why I'm trying to make them in a lowercase, everything, and then I'm going to clean the words and going to return the tweet data, clean tweet data. Okay, this is what the function I've created, and passing this function, guys, apply clean tweet function on my Twitter data. So guys, once I apply this, see the differences. I've kept my old column, I kept my clean data. So you see here, this was in the uppercase, this has having hashtags. Now it is got converted to the lowercase, and now hashtags are removed, emojis are removed, @ is removed, everything is removed. Now data is looking very, very clean, guys. Data is looking very clean. This is what I've done. Apply the clean tweet. Okay, this function I've created and apply on my column. Once I do that, then next thing what I have to do is I have to remove this unnecessary tweets which are like in the Hindi. You can see here this Hindi also, there are some tweets, some are in English, Hindi plus English. All this kind of a reducing I am going to do, guys. Okay, I'm going to do. Then again, I'm calling my lematizer, I'm calling my stop words. All this kind of a process I will be doing here. And once I apply this, once I apply, see here, I'm applying clean tweet. The lematizer, I'm calculating the remove words, remove the stop words, all these things I'm doing. And then I'm going to detect one thing, guys. Now, once I'm going to do this thing, in the last, I'm going to detect the language of the tweets, By this function, language detect function, I imported detect. And from this detect, guys, I'm passing my text, and it should be able to detect what language that text belongs to. And then that I am storing as a language column here. df.cleanTweet.apply this detect language, and it will try to create this, guys, language tweet. Okay. Tokenization, translation, lowercase, cleaning, one word, important emojis, unnecessary language. Correct, sir. Correct. This is what I'm doing. Okay. Then, guys, last in the end, I'm going to understand which language this tweet belongs to. Okay. This you can see here. Once I apply this function, clean tweet.apply detect language function, which I have created, detect language, take the text data, detect language, and return that. Okay. That's what I'm trying to do. And you can see here, I've added a new column here, language column, which is apply the detect language column, and it will show you the detail now. Now you can see some tweets are English, some tweets are Slovakian, some are language, some are Hindi, some are Hebrew, some are other language, right? So this is what I get. And then, guys, I finally decide that I will only do analysis on the English tweets. So I'm going to filter out the English data. Say here, I'm going to English tweets. I'm going to create only English tweets here. English tweets, okay? Language equal to English. I am applying this condition, and I'm going to take the English data, and then I'm going to apply. So this is my original data. This is my clean data. This is my language data. What language this tweet belongs to, and then I'm going to cut out this English tweet. Okay, this is what I've done. Then, guys, my job is very easy. I'm going to convert also this year, month, and day column here. So by using this kind of a timestamp, I'm adding this kind of a thing. And once I add this kind of a year, month, and date by using the timestamp, I'm going to convert them by using this kind of a function. So now my data, tweet, and everything looks very good now. So I can check now how many tweets are done, how many likes are given, how many deets are left. Language criteria, filter out the tweets of non-English. Yes, sir, correct. This is what I'm going to do. Okay, guys, I can now, what I can do is now, the once I am created this kind of things, I can now check on which was the day where highest tweets were done. This kind of analysis I can do on which day, on what date. You can see here on 24th of June. This movie was released in the month of June 23. On 24th of June, there were the highest tweets were done, 12,000 tweets. Okay. So this kind of analysis you can do also. Then, guys, very interesting. When I spoke about this SIA, sentiment intensity analyzer. Remember this function of which I brought up here. Let me go back again and show you that function which I brought up here. Imported this one. Now is the time to apply this function. Sentiment intensity analyzer. Sentiment intensity analyzer, SIA function. This I am going to apply now. Guys, try to understand why I'm applying this function now out here. What is the job I have to do? Okay. So, guys, once I am able to create this kind of a category, then my last thing what I'm going to do is I'm going to apply this kind of a, now see here what I'm going to apply. I'm going to apply, guys, this sentiment intensity analyzer, which is a SIA function. I'm calling this SIA function, guys. And before calling this SIA function, I'm writing one rule. Okay, this SIA function, what we'll do, try to understand. SIA function will create me the polarity scores. Polarity scores. What is this polarity scores? Based on the language. Based on the language, this model is already trained. This NLTK has a trained library. I am going to call this one kind of algorithm, which is sentiment intensity analyzer. This sentiment intensity analyzer give me polarity score, and based on this polarity score, guys, based on the polarity score, I am going to bifurcate them into the kind of a category. So if my score is less than 0.5 minus 0.5, I call them negative. If my score is more than 0.35 positive, I am going to call them positive, otherwise neutral. So this condition I am writing, and I am applying this function si.polarity score to my function, which is called as English tweets. English tweets. Okay. Once I apply, guys, once I apply, you can see here. You can see here that I am getting the polarity scores out here. I will show you the polarity scores out here. And once I get the polarity score, guys, let me show you the polarity scores out here. So this one, the sentiment, and I'm going to call them as sentiment. And this scores, once I get on the basis of the scores, I apply this label sentiment function, and I get my overall sentiment, whether positive, negative, or neutral. Okay, positive, negative, neutral. And once I did that, my job is very easy. My job is very easy. Once I applied this, my training data is ready, guys. My training. This is not done, guys. This is not the end of the story. This I just created the training data because I have to build a future model. So which will take the tweets directly, which will perform all these tasks. And on the basis of the task, it will able to understand whether this movie analysis is positive movie, negative movie, or neutral. So this is just the pre-processing and also training my model for the future tasks. So this kind of a SI score I created, and based on the polarity score, I am creating positive, negative, neutral. And once I add this column, obviously you can visualize your column that how many positive tweets are there, how many negative tweets are there, how many neutral tweets are there. Okay. Now you can plot here. You can create a pie chart. You can create a plt.figure, and you can pass a pie chart plt.pie, and you can pass this information orange, red, green, blue, this color I am giving. And then you can see here. So directly negative, how many? 35% people negative, neutral 38% or 39%, 38.9, and positive very, very less. So I can say overall sentiment was neutral followed by negative. Okay, this is not done, guys. This is just the analysis I have done as of now. Okay, from the tweeted text data, how the value is calculated. Okay, guys, how the value is calculated, I don't understand this one. Very nice question. So this one. So when I have a tweeted data, right? I have a tweeted data. I have cleaned my data. I have this clean tweets, right? English tweets. So now what is happening? Try to understand. I call this function. Guys, try to understand. I call this function SIA. This SIA function is already trained in the analytical library. So it can understand. It is trained on the words like which word is positive, which word is negative. Okay. So that kind of a training is already done. That is the algorithm SI, sentiment intensity analyzer. I am calling that algorithm. When I apply this here, SI.polarity score. SI.polarity score on that sentiments. This creating as a sentiment column, and I'm passing here what I'm passing English tweets. I'm passing English tweet to this function. So what will happen? So this algorithm will take, okay, this algorithm will take the data. SI input is the text data. Correct. SI input is text data, man. Correct your understanding. I am giving my English tweets here. I am giving my English tweet data, right? This English tweets, whichever the right tweets are there, which I filter on the basis of English language, that I am passing. Then it is creating the scores, guys. This overall scores, and on the basis of the score, I have written a condition which is positive, which is negative, which is neutral based on the scores, and that's how I am getting my overall sentiment, guys. Clear, ma'am? I hope I am able to answer your question, ma'am or sir. Okay, sorry for that. So, guys, once I get this, I can do a value counts. I can do value counts. How many neutral, how many positive, negative. I can plot the data. Guys. Once I plot the data, guys, what is the next thing I have to do? Try to understand here. What is the next thing? I can create a word cloud also. Word cloud. This kind of a word cloud. So I am creating word cloud for positive sentiment, negative sentiments, positive sentiment, negative sentiment, and overall sentiment. Three kind of a word cloud I am creating. How to create a word cloud? Very simple. Very simple. How to create a word cloud? Import the word cloud function. Then pass your column. So I am seeing English clean tweet data. I am passing, and I am passing this. This is overall tweets, and then I am creating positive tweets and negative tweets. Okay. And then you have to write one function, word cloud. How many maximum words you want? What is the width of the size, width and height of this banner? And then you have to pass the data. You have to pass this data, okay? This clean tweet data. And that's how once you say plt.show, it will create this kind of a word cloud, guys. Very, very simple thing is there. So you have to pass this data out here, and that's it. Your job is done to the function word cloud. Maximum word, width, height, and your data, guys. Join the data. I'm passing these things, and it will create this word. Now you can see I have created this for the overall sentiment equal to positive. This kind of a data I have taken, and then I am passing this maximum word, width, height, and my data. This data is equal to positive sentiment. So this you can say what are my positive sentiments which are coming very times. What are my words which are very positive? You can say Adi Purush Day, dialogue, share, watch, video, book, ticket, sir, movie, change. These are my important words which are repeated again and again. Very, very important. These are positive words. This way you can create a negative words also. Court, box, cry, critics, office, date, right? Same thing I have done, same thing. Negative sentiments I have taken and passed this to the word cloud function. That's it, guys. Okay. Again, guys, once I am able to do this, what is my last job? Last job is, guys, simple. Split your data into training test and call your model, because you are creating a future model. So in future, if you pass the tweets, it will be able to understand what is the positive, negative. I am passing my data to this train test split, and I am calling my function here, count vectorizer, by using the count vectorizer, or you can call a TF-IDF also here. Last thing is you can call a TF-IDF. You can see here we are calling TF-IDF tokenizer also. This one TF-IDF transformer. You can call a word counter, word count vectorizer. There are methods I am showing you. Count vectorizer. You can call this TF-IDF, and from TF-IDF you can transform your data. So, and once you transform this data, guys, now you, or this one is the advanced technique, word embedding, right? Using the Keras. I'll explain you guys how it is able to convert this word to this one, this kind of a number, word embedding layer. And then, guys, once you apply this, that is the time I'm calling my model here. My model is naive-based model, multinomial, because I have more than 2 categories. I have a 3 categories. So that's why I'm calling my multinomial naive-based model, naive-based algorithm. And then I'm saying naive-based model dot fit training data and test data. And then this, once it is fit, guys, I can do predict now. I can pass a test data. I can do a prediction and look at my accuracy score, which is giving me accuracy of 75%. Amazing, amazing accuracy. Now, this is not only one thing. You can create such model. You can create a pipeline. You can understand which counter you want, which converter you want. You want a TF-IDF, you want a count vectorizer, which algorithm you want. You can create this kind of a pipeline, pass the algorithm, perform the training, and you can check the scores. Here also, I'm passing one more idea here, and I'm trying to pass this kind of a XGBoost classifier, advanced algorithm, ensembling technique. I am creating one more algorithm, XGBoost classifier. This XGBoost classifier I'm passing. Now I'm checking my pipeline. So, okay, I'm passing this kind of a vector. I'm passing TF-IDF, and then I'm passing some parameters, learning rate and number of estimator means. This kind of a 80 decision trees I am passing. And then, guys, I'm checking my score. You can check your same score is coming. And this is how you can do a prediction. We have 5.8, guys. This is, guys, this is end to end, and this is the end to end, guys. This is end to end. All right, guys. So I hope you guys had understood how to create an industry grade project. Okay, guys, this is industry grade project. If you guys can manage this kind of a things and this your model is ready, you just have to apply, guys. You just have to apply this model in the application. What application you have to create? Like this way. So you have to create one user interface. There you will give this kind of a text that please enter your tweet here. Please enter the tweet, and there will be one button here called as predict. And once you predict the button, guys, here in the end you will get whether your sentiment is positive, your negative, and how much is the graph. Like you will give the graph, this kind of a graph as a result. Okay, here you have to enter the tweets and this kind of a model. This model will call here, all this model, it will perform prediction, and this will give you a result like this one. Okay. So yes, sir, we'll share our attendance link here. I'll share this Jupyter notebook as well here immediately for you guys reference. So Chandana, can you please share the attendance link and feedback link? People are asking for that one simultaneously.
Yeah, I sent Vikas.
Okay, thank you. So guys, Chandana has shared this feedback link, guys, and I will immediately share with you guys, and I will upload also this in the LMS portal, so it will be available, guys, for your practice again. Yes, yes, guys, ma'am. Yes, we'll upload this video also. We'll give this one video also. Your entire thing will be available for you guys then. So let me see if I can share this notebook with you guys here immediately. So I don't want to delay your guys learning. So give me one moment, guys, and then I'm going to explain you guys in half an hour advanced technique, which is recurrent neural network, guys. Recurrent neural network. Okay. I'm going to understand very, very amazing concept. I'll explain you, and then we'll make up one fake news detector. One fake news detector I'm going to perform here. Okay. So guys, I already shared this notebook with you guys out here. In the comment section, guys, you can find my notebook, adipurush.ipynb. So you can refer to this data, guys. You can refer to this data. I'll share my tweet data as well. So you guys will have a data file also along with you. I'm sharing my CSV file as well for this. So you can upload this data and you can run the code on your own. So I don't want to delay. The same material will be available, guys. Same material is also available on the LMS. I am sharing with the LMS team also. YOLO NAS notebook. Yes, sir. I will also share, ma'am. YOLO NAS notebook. That is a Google link. I will also share with you guys. Give me one moment, please. Okay, guys. So yes, guys. I am sharing my information. Yes, ma'am. Chandana, note taken. So I'll finish in next 15 minutes. I'll give you guys what is the recurrent neural network. I will make a code walkthrough. First.learn@gmail. Yes, ma'am. I've shared my information, ma'am. Manjula, ma'am. Dr. Manjula, sir, ma'am. Sorry for mispronunciation, sir, ma'am. I've shared my contact. Okay. So, guys, let me also share this one. This is better that we got like 15 minutes. So I will provide all the material. Don't worry. Every material will be provided. YOLO NAS to everyone. So first, let us quickly finish our recurrent neural network, and let me make you one more code walkthrough. One more code walkthrough. Let me finish this one because yeah, this is very important. Then we'll give some time for the principal sir and other lecturers to express their feedback. So let me take you very quickly to my next presentation. I will at least give you a hint like how the recurrent neural network works upon, and small 5 minutes code walkthrough I will give. So let me share my screen, guys, back again with you guys. Just a moment. All right, guys. So let's try to understand what is the recurrent neural network. So let me show you what is recurrent neural network and then try to understand this one. So guys, I hope everyone is able to see my screen as well. Okay. Yes, I'll share this one. Okay, I've shared the guys. I've shared the things. So let's try to focus here. So for 10 minutes, please give me 10 minutes. I'll focus here. And just give me one moment, guys. Just give me and try to understand this one. So let us finish. So try to understand recurrent neural network, why they are important, guys. So let's understand this kind of activity. Okay, let's understand this kind of activity, guys. So what do you mean by? So what do you mean by kind of things which are available or which can be done using the recurrent neural network? First, guys, recurrent neural network will help to perform a time series data analysis, text convergence, image and audio data. Let's imagine you give a text, guys. You give a text, on basis of text, it will create a video, guys. On the basis of text, it will create a video. So that kind of a test, speech recognition, question answering, machine level translation, handwriting prediction, opinion mining, all these jobs are done by recurrent neural network. Try to understand what is this recurrent neural network, guys. Let's imagine, guys, let's understand here that, okay, let's understand what is the problem with the normal artificial neural network. Let's imagine that I have this huge big data. This huge big data is there, and this huge big data has the 10,000 words. Well, obviously, this 10,000 words will become my inputs. So when I pass this, guys, this is artificial neural network. When I pass this, guys, I have to create that many input nodes. Understand here. So one word will go as one input here, 1, 2, 3. This way, guys, I have to create a 10,000. I have to create a 10,000 nodes, which will become very, very big neural network, which will become big artificial neural network, which will fail, guys, which will fail because of the computation speed. That is why we have to call a recurrent neural network, guys. Recurrent neural. Try to understand what is the recurrent neural network and how it will help, because we have to pass this big data, guys. This is what the recurrent neural network look like, guys. Try to understand how the recurrent neural network look like and what is the beauty of the recurrent neural network. What is happening here? So this is, guys, folded version. Okay, this is folded version, and let me tell you what is happening here in the recurrent neural network. Let me write this way: I am Vikas, and this sentence I have to translate to the German now. To the German, guys. What is happening? What is going to happen now? So I have to pass this sentence: I am Vikas, and this will get converted to German this way: Ich bin Vikas. Ich bin Vikas. Since I am taking German classes, guys, so I can understand the basics. So Ich bin Vikas, this is how it will get converted. Now try to understand what is happening here. So I have to pass this kind of entire sentences, guys, to my model. And if I pass this to the normal artificial neural network, not possible. That many 1,000, 10,000, 10,000, 100,000, 1 billion neurons I have to create, okay? Which become very, very large architecture. For that purpose, guys, for that purpose, they have created a special architecture which is called as recurrent neural network. Now, what is the beauty? Try to understand. This is a folded version. What is happening here? it is taking data one by one, guys. I am because it is creating a recurrency like this way. First, what will happen? I will go inside, guys. I will go inside. Then it will get multiplied by one weightages, one weight here, and inside it will go inside the neuron, guys. Okay, it will go. Okay, thank you, sir. Thank you, Umar Swami, for your kind words. Okay, I'll remember this one. So, guys, try to understand what is happening here in the recurrent neural network. So, this will take here one word at a time. It will multiply by weights and it will do a processing. It will create one output one. But what will happen next time? Next time, guys, it is not the new neuron. Again, same neuron will work. Same neuron will take next output here. I am. And then it will get multiplied by weights and then it will create a one more output, O2. Then, guys, this O2 will given back again, this O2 will be given back again, and then it will take one more new output. Means what is happening? The previous output, it is getting combined with the next input. Okay, this kind of a combination and that getting multiplied by weights. So this is what is happening by this way, guys. By this kind of a mechanism, it is able to accommodate. It is able to accommodate, guys, entire sentences, large sentences within the single neurons. That is why the recurrent neural networks are different, guys. That is what. Try to understand. If I unroll, guys, this is C. So this is what I was talking about. If I unroll, you can see here, it is taking multiple inputs as per the time. Because I am passing this, I am because, okay, it is trying to take this one by one. See here, same neuron is there. If I unfold them, this is what is happening. It is taking I at a time one. Then whatever this I is taken, it is getting multiplied by weights and it is creating one output. That output is again given an input to the next time. Okay, the neuron is same. Whatever I went in, it is getting multiplied by weights and then it is creating some kind of output. That output is getting as an input along with the next input. So now my inputs is getting combined. Now am is getting combined with the I kind of a thing and then getting processed at the second time two. This is getting processed. And now at time two, whatever result comes in, that time to result is also processed again with the third word. This kind of a chain I am creating. So I am creating this kind of a chain. So this kind of a chain when I am creating, it is able to accommodate the larger data. Also, it is creating kind of a link. It is creating a link with the timestamp, and that is why it is able to understand the entire loop. And this is how, guys, this is how it is trying to create called as a recurrency, and it is able to understand the words and sentences. It is able to establish the link and the connection with the entire sentences, and then these entire sentences are then analyzed together. That is why it is able to do this kind of a task, machine learning, machine translation, all this kind of a stuff, guys, all this kind of a stuff. So that is the beauty, guys. That is the beauty, and this is called as recurrent neural network, guys. Okay, this is the called as recurrent neural network, and this neural network can also take the same thing I have written here, guys. You can have this kind of explanation written. This is the main aim. So when I talk about the new state consists of what? New state consists of the input of the old state, or sorry, output of the old state. HT0 is the output of the old state. This is getting combined again with the new input. This XT is the new input. Okay, this combined with the weights and this become the new state, guys. This is what happens, and this is how entire things. Let's imagine I pass this sentence, it get converted to the words. This word get converted to the recurrent neural network, and then it perform with all the dimension, and then we get our y-hat prediction. All right, guys. So this is what is recurrent neural network is all about. And for your explanation, there will be multiple such layers. So that is called as deep recurrent neural network. So here we were saving only one layer. So here you can see there's a one more layer out here, and which is stacked above each other. So stacked above. This is recurrent neural network layer 1, and this is recurrent neural network 2. So this way they are stacking this. This is called as one to one, one to many, many to one. This kind of a recurrent neural networks they are creating. Yes, sir. I will share this attendance link once again with you guys. Okay. So I am sharing once again attendance link with you guys, so you can refer to this guy. So this is called as recurrent neural network, guys. So let's try to understand this recurrent neural network. I am leaving this, guys. I am leaving for explanation. Let's make a code walkthrough, simple code walkthrough with this one. 5 minutes code walkthrough. I am done, guys. I am done. Then let's give me 5 minutes for this code walkthrough. Very, very important code walkthrough. This kind of a recurrent neural network I have taken, and then on the basis of that, I'll show you how to create one fake news detector. Fake news is a very, very simple operation will be there. Fake news detector, and try to understand this one, how it is going to understand this one. Fake news detector. Give me one moment to share this with you guys. Just one moment. I'll share and make a 5 minutes code walkthrough. Okay. Now it is open. So let me show you how the things will work. Link it. Yes, sir. EDL team will help you, Vani sir. The EDL team will help you this one. Guys, let's have a quick code walkthrough. I wanted to show you this fake news detector, and then we'll finish this one. So how to create a fake news detector? Okay. So guys, try to understand. I'm taking one. You can take even a fake news detector from the Google as well. So you can directly take this for Google News. So I am creating this data from the Kaggle data set. I have taken this data as a data frame. Now try to understand what is there in my data. In my data, guys, there have IDs. There have a title, who is the author, and that is the entire news. This is the entire news. And guys, in the end, I have a labels like 0 and 1. So 1 means fake, 0 means correct news, genuine news. Okay, this kind of a things I have. Okay, let's try to understand how to build this kind of a news detector. So obviously, guys, when I have to build this news detector, obviously, what I can say is I have to do all the steps like we did, like text pre-processing, stop words, what to convert, numericals, try to check the null values, remove the unnecessary column. All this process I will show you fast. So guys, this ID column is unnecessary because I don't need ID column. Then I have to understand, is there any null values? Okay, is there any null values? I'm checking the null values. Then I'm checking. I have a 7,000 news, guys. I have a 7,000 news, and this kind of a news I have. And then I'm dropping the null values. Then I can drop this ID column. Okay, I can drop the label column. And once I drop the ID column, label column, guys. So I'm importing my now this guys. This is the advanced deep learning technique. So I'm importing TensorFlow, Keras model, TensorFlow model, and this LSTM, guys. This is my model I'm going to use for sequential. This is my sequential model. Remember this model, which was the same model which was used in the CNN, same model, but layers I am using LSTM, guys. Okay. So this one thing I am using. Then guys, we have to remember what is the vocab size you have to create like this one. So vocab size means whenever I am converting my word to vector, I have to create one limit, like what limit I have to take, and within that limit I have to do a encoding. So that kind of a vocab size I am creating. And then guys, whatever data is there, I'm separating my X and Y. Means Y will be my target column, X will be all my feature like title, author, and text, guys. Once I do this, guys, once I do, I have to create all the pre-processing like stop words, removing the punctuation marks and everything. This is what I'm doing here, guys. Stammer, all these things I've done. I am cleaning my data, guys. Once I clean my data, guys, see here, my data is clean. Then what I have to do is I have to call the word embedding, one hot encoding. One hot encoding means whatever vocab size is created, all these words will be getting converted to the vector of that sizes. Okay, you can see here. And once I convert them, guys, once I convert them, what I have to do is this is called as embedding representation, guys. Now it is not the time, but I can simply say it one words like what is word representation, what is the this embedding layer will do. Let's imagine what will happen. They have create this kind of a vector out here. So let's imagine I say one word like or love. So these are two same words. What is happening? So let's imagine I take a vector size of 5,000. All the words will be stored this way. 1 or 0, 0, 0, 0 will be there. And let's imagine this love word and like words are created like this way, vectors. And let's imagine this love word stands at a 1,000 position. So at 1,000 position, there will be 1 and all other words will be 0. Right? All other numbers will be 0. Let's imagine this love word stands as 1,001. So at 1,001, there will be 1, other will be 0. Okay. So this kind of a word to vector is created, guys, that 5,000 size number. You know, guys, this is very critical, that this 5,000 verse is very awesome high dimension. So that is getting converted into the kind of a feature representation. Means what? Try to understand. One liner explanation I'll give and make a code walkthrough and try to finish within 2 minutes, guys. I know I have only last 2 minutes. So give me 2 minutes and I'll explain what is the feature representation. What's it? Feature means what I will do is, guys, if I have words like this one, man, woman, king, queen, okay, and this I create here kind of a features like say human being. I'll create a human being. I create a feature like royal. I create a feature like food. So guys, on the basis of this feature, I'll try to relate them. Like man belong to human being, yes or no. Then I give a score like this one. So woman belong to human being, get a score. So king, they are human being. Yes, queen, they are human being. Then royal. So I can say that for royal category, can a man be a royal? Yes. So accordingly, guys, I create this kind of a embedding. This is called as feature embedding, feature representation. So by using these, guys, whatever 5,000 vectors I was creating, 5,000 size vectors, these are getting converted into how many? How many features I've taken? 1, 2, 3, 4, 5. So I am getting converted into the 5 dimension, guys, from this 5,000 dimension. So that is created here. So that is same is called as this one. Yeah, guys, I will share the attendance link once again with everyone. Okay. So I'm sharing this link, guys. So last 2 minutes, guys, and we are done with the code walkthrough. So that is why, guys, and this is padding sequence means, so whatever lengths, if I'm saying my length sentence has to be 20, then I have to create the 20 lengths for each and every sentence. So that's why I will add a zeros. So let's imagine my actual sentence size is only 10. So if I'm saying make them 620, so I'm adding this zeros, guys. That's what I'm doing. And this is what is called as word representation. So once I do this word representation, simple, guys, call my model sequential, add a embedding layer. This embedding layer will convert the word to the document. So I'm calling my model sequential. I'm writing how many features I want, 40 features. Call that layer embedding layer, pass your sentence. Then I'm calling this model, guys, LSTM layer. Okay. So I have to write now. Okay, guys. So, okay, Aman. Thanks for the confirmation. So, guys, try to understand what I'm trying to do. Okay, I'm not going to rush. Like I explained you what is called as padding sequence and what is called as now feature representation, right? You can see here that using the free feature one not encoding, I converted my this kind of a entire text into the numbers, right? You know, entire text into the numbers. So this is what I've done, guys. And then what I have done is try to understand. So you can see here, whenever I created this numbers into the sentences, guys. Yes, sir. I will share this file also with you guys. Don't worry. So you can see here the consistency is not there, guys. Some are having length of 8, some are having length of 10, some are having length of 12. So I am going to do is I am going to convert them to the same sentence length, same sentences. So that is called as padding sequence, guys. That is called as padding sequence. Let's understand this one. Let's understand this one. So this is the entire token like I have created. So let's understand. So this is what I am trying to do, guys. That is called as padding sequence. So padding sequence means what simply? So if I want to convert them everything to the fixed length, so I have to bring them to the length of 20. So what will happen? Some are of 10 length, some are of 20 length, some are of 12 length, some are of 15 length. So whatever length is there, if I want to make them to the 20 length, obviously after 20, I have 12 here, I have to add that many zeros. So all of them become the same length. Okay, that is called as padding sequence. So add the zeros whenever there is a not enough length. Okay, by adding zeros, guys, by adding zeros, I'm making them an equal length of 20 sides. This is what I've done. Okay, and once I've done, guys, once I've done this kind of a things, now what is the main task? Create our model. Last part, guys, last part. Create our model. So I'm saying that take my feature representation as 40. Take my okay, sir. I will share these things. Okay. So this feature representation I'm taking 40 means 40 dimension I have to create. Then I'm calling my model, guys, sequential. Try to understand this sequential model is there. It is same model which I have used for artificial neural network. Is the same model which I have used for the convolution neural network. For here also, guys, when I'm calling my recurrent neural network, I'm using the same model. Only layers are changing, guys. Only the layers will change. Try to understand. Here I'm adding my sequence of the word embedding, because whatever words are there, I'm going to convert them into the numbers. That layer is there. This is called as embedding layer. And then, guys, I'm adding my bidirectional LSTM. This LSTM here, guys, here you have a choice. Like I'm using the advanced model LSTM model, which is a higher version, higher dimension version of recurrent neural network. So I am writing LSTM in bracket. I'm mentioning how many neurons I want. How many neurons I want. That means neurons will be created. Like on this diagram, remember this kind of a diagram which we created, recurrent neural network. So how many such neurons should be there? So that is called as here the 100. So instead of LSTM, guys, you can write this one RNN. If you don't want to create a high-end model, you can create a RNN also instead of this LSTM. So this is what we can do. So by using this, guys, you are creating which kind of a layer you want to add, RNN layer or LSTM model layer. Okay, here is this layer is for the embedding, converting the text to the number. Okay, word embedding layer, and this is my model sequential. Once I mention this thing, then my last layer, because my last layer I have to tell whether this is a fake news or not fake. Okay, fake news or not fake, guys. Okay. Okay, guys. Okay. So I will share the content. Yes. Okay, guys. Give me 1 minute. So, guys, once I am able to add all this my LSTM layer, word embedding layer, and my sequential model, last thing is to add a output layer. So, output layer I am taking only one, guys. Output layer I am only taking one because I only want a yes or no, like fake or not fake. Okay, this kind of a things I want, whether this news is fake news or not a fake news. Okay, this kind of a things I have to write. So that is why I'm adding only one neuron. That is a dense. and I'm taking this activation function. Then I'm combining my loss function, optimizer Adam, and matrix accuracy. Okay. So this way, once I perform information, guys, that's it. My job is done, and I can check my model summary, guys. Okay. So this is the entire explanation how you creating the recurrent neural network model. That is the LSTM model, advanced level model, with for creating the fake news detection. Once your model is ready, guys, you can execute this one. You can check the same thing has been created. That's it, guys. Once you created, you split your data, above data, into train, test, split, and pass your data to your model. Model.fit, pass your data and pass the batch size. Epoch means 10 times, please run them. 10 times it will run and it will take the data in the batch size of 32. And this is your model training. Once your model training complete, guys, this way you can check your accuracy also. So accuracy is reaching to 99%, and this one is reaching to 90%. So you can do a predict, model.predict, and you can check, like you can write here where the prediction probability, where the prediction probability is more than 0.5, then it is 1, means fake news. Otherwise, it's a genuine news, 0. Okay, this kind of a condition I have written, and I can check the accuracy score coming to 90%, guys. Okay, all right. So this way, guys, this we can create an entire end-to-end application. This I have created using LSTM model. So you can use a recurrent neural network model, and you can create a fake news detector, guys. All right. So hope you enjoyed this entire code walkthrough. So you found it useful, guys. We have checked 2 projects here. So one was for this entire movie analysis. One was for the advanced recurrent neural network layer model, which is a fake news detector, guys. Fake news detector. So I'm going to share, guys. Also simultaneously, I will share this notebook as well, guys, for your information. Okay. So I will share this information also, guys, for with you guys. So let me understand this one. Just give me 1 minute, and I will add this, guys. Okay. Just 1 moment. I will add this notebook, and I am done, guys. Just give me 1 minute. All right, guys. So send the link for the recording video. Yes, guys. My team will share with you, all of you. Okay, this recording link and everything. So let me understand this one. The last thing, I am sharing this Jupyter notebook with you guys. So you guys don't have to worry. You can practice along with this one. Okay. So I am adding this data also, this fake news data if I have available. Or you can download, guys, any news data. It is available on the Kaggle. Okay. I don't have actually data with me as of now. So I am sending this Jupyter notebook, guys. So I am shared it here. Okay. So this same thing is available on the this code is available on the LMS also, guys. I will share with the LMS team also. So you guys have a video available with you. You have a code available with you. Everything can be referred from the LMS team, guys, from the LMS dashboard. Okay. So all right, guys, that's it for today. I hope you guys understood from basic NLP to the advanced level NLP how to create this one. So guys, thank you very much for your patience, and I hope you enjoyed this entire NLP session as well, along with this computer vision session. And I would say thank you very much and wish you good luck for your projects then. And hope you found this session very fruitful. So you can add to your knowledge and you can create this kind of a live things for computer vision and NLP, guys. All right. So that's it, guys, from my side. Thank you very much. And over to Amar and Chandana then.
Yeah, sure. Thank you. So first of all, I would like to thanks our trainer, Mr. Vikas Narune, for such a wonderful sessions for 5 days. Thank you so much. Chandana, I hope my voice is loud and clear. Can you please confirm me?
Yes, sir.
Okay, so be like, thank you so much for NIST for collaborating with ExcelR and making this FDP successful. And most important thanks to all the participants to making this program successful. Without your participation, it's not possible. So thank you. And coming to the certification part, so those who attended 60 and more than 60% of the session, they will receive their certificate via registered email ID within 7 to 8 working days. I will repeat once again, regarding to the certificate, those who attended and marked their attendance using Google Form, 60 and more than 60%, they will receive their certificate via registered email ID within 7 to 8 working days. Yes, coming to the LMS, so you will get all the material, recorded sessions, all these things over LMS, and all that things with you for lifetime. You can access that anytime. Okay. And if you have any query or question for me, please drop me a message over Zoom, and YouTube participant also. If you have any query, please let me know. I will take it up. If any suggestions, if any feedback, please go ahead and put it over there. If you want to unmute yourself, you can unmute yourself and suggest few things or give the feedback as well regarding to the training programs. So I'm giving you the access to unmute yourself. Yes, done. Anybody would like to talk regarding to the FDP?
Yes, sir.
Oh, yes, please.
Hello, sir. Myself, Subramanya. So
Yeah,
I am
yes.
the assistant professor in Nagarjuna Engineering College, sir.
Okay.
So the program is really good, sir. We
Yeah,
have learned
thank you,
many
sir.
of the things from the trainer. Even I would like to continue some of the things and some discussion need to be done with the trainer also, sir.
Okay.
So can you provide either a number or a email ID, sir?
Yeah,
In that
definitely.
case,
We'll take it forward for same situation, also same query. Drop an email to edl@excelr.com. We'll try to connect with you to the trainer. Okay.
sure,
So I'm
sir. Sure.
sharing that email ID with everyone in the chat box. Going forward in the future, if you're facing any difficulty, if you're feeling that after 7 or 8 working days you not receive the certificates, please drop an email to edl@excelr.com.
Sure, sir. Sure.
Yeah.
But the rest of the program was very good, sir. I have learned many of the things, and even I came to know many of the things, sir, by this FDP program.
Thank you so much, sir, for such a wonderful feedback.
And thank you, sir.
Yes.
Thank
Hello.
you, thank you, Subramanya,
Yes.
sir. Thanks for your feedback.
Yeah. Good evening, everyone. I'm Dr. Bharti Kavde from MIT Arts Commerce Science College, Anandi, Pune. I am the coordinator for these particular courses, whatever are conducted by ExcelR, FDPs, as well as different training programs, as we are having the MOU with ExcelR. And I appreciate the efforts which are taken by these particular team members, organizing all the things, whatever the training programs are conducted, whereas FDP is also conducted. And I'm very happy to share that my PhD topic is regarding data analytics. So I am very much close to these particular things, or rather I can say these things, data analytics and whatever the NLP and computer vision, all these things are very close to my heart. So I have learned many more things from this particular FDP, and I'm sure that it will be helping to one and all who are attending these things, because nowadays it is very much, we can say, need of an hour in terms of prediction and all those things. So thank you very much for organizing such kind of new technologies for us. Being a faculty members, we must be aware about all the recent technologies, and we must be having hand in those things in terms of teaching as well as learning number of things which are coming in recent technologies. So thank you so much, everyone. Thank you especially to the trainer. The things were explained in very simple and very what we can say, easy language. So I'm very thankful to that.
Okay,
Thank you very much, everyone. Thank you.
Thank you, Bharti ma'am. Thank you for your kind words. I am really delighted that I am able to deliver the knowledge to you guys. So thank you very much once again for your feedback.
Yeah, thank you so much, Bhartima, for such a wonderful words. Anybody else would like to talk? We have 7, 8 more minutes. No, okay. Yeah, we'll wait for 5 more minutes if anybody would like to talk. Meanwhile, if anybody have any query or a question, please post in the chat box, Zoom and YouTube participants as well.
Sir, am I audible?
Yes, you're audible.
I'm Kavita from CMRIT Bangalore. So I met actually last week a person from ExcelR to get an
Okay.
MOU with for conducting this type of events. Then I asked like everything you're giving as a free of cost, and like what will be the quality of your program and other things. So he shared this particular link to attend and check the quality. Really, from my bottom of heart, I'll tell you the trainer continuously repeating the things again and again. Really, it was very good, and I liked the program very much. So I'd like to thank ExcelR and the Vikas, the trainer especially. Thank you for the arrangement.
Yeah, thank you so much, Kavita ma'am. And we're looking forward for the MO in collaboration with your institute.
Yeah. Yes. Really, I'll recommend to the management to go for
Okay,
MOU.
yes, sure. Thank you.
Thank you so much.
Thank you, Kavita ma'am. Thank you for your words.
Thank you, sir.
Yeah, guys, please go ahead, unmute yourself. If you want to speak, express yourself, you want to let me know about the session feedback, please go ahead.
Hello. Hello, good evening, sir.
Yeah, yes, sir, Abhaya, sir, go ahead, please.
Yes, actually, sir, I am from KIT University. Now I am currently working as an associate professor in KIT University. And my area is actually I'm working on image processing recommendation system using deep learning, machine learning, biomedical image analysis. And whatever I have learned in this particular FDP program, mainly thanks very much, sir, to Vikas sir actually. Because sir, you are actually uh, explaining the code, everything. Actually, I am very much happy for you. Actually, your presentation and your the way you are teaching that part also. That means you are a main best teacher also, and also another one is coder. With both qualities you have, you may be converted into industry part, you may be converted into academics part. So whatever I learned in these 3 or 4 days, I think that this is 100% I am touching with you on the future also, and also I am getting maximum implement mainly in your teaching career. Maybe implementation point of view, actually we are lagging actually. So here from this particular lecture, whatever I have learned from you, sir, actually my implementation point of view, confident power already I got. That's very thank you, sir, and also. Yes, sir or ma'am from NIST, because that particular college actually providing our this particular platform, so that I have learned this. The both actually ExcelR and also hosting side that NIST college. Thank you all of you. Thank you, sir.
Thank you, sir. Thank you for your kind words.
Good evening, sir.
Yeah, ma'am, go ahead, please.
Sir, good evening, sir. Sir, this is the fourth FDP I'm attending under ExcelR, and I'm learning a lot, sir. And today's the speaker is very good, and we learned so much, sir. But I missed 1-2 sessions. But the way explanation and the case studies and everything, really, I thank to ExcelR and the speaker, sir. Thank you so much.
You're welcome, ma'am. And those sessions you missed, na, definitely you can go through the LMS. You will get the record sessions as well. So no need to worry.
Yes, sir. Yes, sir. Thank you.
Yes, thank you. Okay, then we'll conclude for the day. And thank you so much for making this FDP successful. And we'll see you again in the next FDP. Once again, thank you so much to our trainer, Mr. Vikas Narone, for such a wonderful session. Thank you, Chandana, for being there and giving the good technical support, and entire ExcelR team and with NIST as well. And that will conclude for the day. Thank you so much. Chandana, you can wind up the session.
Yeah, thank you. Thank you so much, Vikas.
So thank you, everyone. Thank you very much. So I wish you luck, guys, for your best projects, and see you in next FZ session then. Thank you very much, guys.